So oh sorry, I've been speaking for a long time and I realized my mic was off the whole time. I suck as a streamer. Okay. Yep. And then we are like taking, we are like right shifting the lower bytes to 28 bytes and like keeping the 4 bytes only. Yeah. And then we are like putting it into function selector, and we are checking if this function selector is equals to this, which is like 4 bytes of function selector. And if that's the case, we are storing this, which is basically and we are doing an on the implementation slot. So implementation stores the address of the implementation, and then we're just returning it, right? And the question here is that what does and here does here? Bitwise AND operation, how does it help? Store as low storage. Okay, it cleans up the data and just returns the address of the implementation. Then we are storing the admin slot, admin slot, yes. And then we are checking if the function selector is this, which is the value of admin, and we just load the admin slot and store the value here, and then we are returning the value which is stored here and returning the 20 bytes offset, or basically 20 bytes of data. And we are checking if the caller is same as the admin. We are like loading storage from here. And if this is very interesting, so I spent quite some time here. I was stuck since, as I mentioned, that I'm not really efficient in reading the assembly code, right? So let's just walk through it. So first of all, let's break down the inner pieces. So if it's basically checking if this string is like matching here, right, the function selector. If not, as I mentioned that for any given statement, right, anything which is non-zero is always considered as true, 0 is considered as false, right? So when if this is wrong, right, so it will like return false, which is 0. And we are like doing multiplication 0 on the admin slot, which will return 0. And then here we are doing is like, let's suppose this is true, right? And this is function selector is this, and when we multiply 1 by the implementation, it is the implementation itself, right? And then when we are doing upper or between the two values here, which is the one when this one will be 0 and this one will be the implementation slot itself, right? So what happens is that the OR chooses the one which is non-zero, right? And returns it. So why does it do so, right? The question is why OR will return this, because OR basically flips this, like if there are two bits 1 and 0, the result will be 1, right? If there is a bit which is non-zero, so if which will return, basically if you are doing that with a 0, it will return the same exact thing. So the address will be either of the two, and if true, uh, if this is true, we are storing if we're storing, yeah, just a second, and we're doing and on, what is and, let's understand and. Not this. So I'm just keeping a note here, like I can do one thing. I can move here, and I can just do this here, and I can do this. Bitwise or if one bit any where was it? If one bit of any two operands is 1, the result be 1. For example, 0. Can I draw here? Yeah. So I can draw, right? So for example 0 and there is 1, the result will be 1. If there is 1 and the other one is 1 as well, the answer is 1. If the other like both of them are 0, the answer is 1. Yep. So this is bitwise OR, and am I still live? Thank God. Yeah. So Okay. Then we are basically, yeah. So let me just la 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 twice, and if one of the both, for example, we create in 1 and 1, the answer will be, move it here, the answer will be 1. If 1 and the other is 0, the answer is simply 0. They both need to be, if both are 0, then the result is 0. Fine. And what we if this is true, the address slot is non-zero, right? If the admin slot is non-zero, then we just store the we just store the address slot which is here, and write whatever the call data is given. We just store it on the address slot. The value is depending on whether this is upgrade or change admin, right? And then we are so this is happening on the proxy itself and implementation. Yep. So I don't understand this here. So yeah, so what it is doing, it is asking like it is doing an and operation on the address mask, which is like 20 bytes are like non-zero and the 8 bytes are zeros, and we are loading the implementation into here. So we are like creating the correct implementation, like this is the actual implementation address, and we are checking if the if these are same, which is called data size is equals to this, like an empty call data, right? Then what we are doing is that if checking if address 0, if the implementation address is not set, then we are loading default implementation. I really don't understand the logic between default implementation, so I'll just skip it for now because I really don't understand here, right? So if, and by the way, this only runs when the call data is 0, but the other functions that we were reviewing, right, the call data is expected to be greater than 1, right? Because we are reviewing these function signatures, right? So by the way, we have implementation address now, which is the address of the implementation contract. So we are copying call data copy, which is destination offset, how much data we offset, destination offset. I think destination offset is basically copy data input into the current environment. This is the destination offset in memory, and this is the offset that we want to read, and this is the call data that I want to read, right? If is 0, if the implementation is not is set, actually is 0. Sorry, if the implementation is address 0, not non-zero but 0. Yeah, let's just understand. I still don't get the this usage of this default implementation. Yeah, so I want to understand I still can't understand, so let me just try to understand, like in what cases admin let's okay, never mind, let's just read through. Yeah, I think today's stream, I think I'll just leave it here only, because I'm kind of confused on this. But let me see. Yeah, what's this doing? Creation code, I think. Yeah, very cool. I think I'd love to see the equivalent Solidity code So I'm just reading through right now, and maybe tomorrow we'll create a like no, for sure we not maybe, but pretty sure that I'm gonna create like my robot for this piece of code, and we'll like create sections of what like the CFG ourselves of how everything is working, right? What are the if conditions, what are jump and all. But interestingly, like this is very complex at first, because but it is a good way of learning low level languages, and I trust me, I learned a lot today, like how things are working and what is the intention of the author here. So I'm pretty happy, but although I'm not pretty happy about the performance that I streamed, my streams were not of par quality, and also did not do well in terms of coverage. So for tomorrow, I'm targeting reading through the EAP Sensonoty proxy code, and then we'll also review Sensonoty lib, which is basically basically used for deployment of proxy and other stuff. Are we calling it or not? No, you're not. Then how is it? That's pretty complex though. I need to understand the logic for default implementation and implementation. So tomorrow we'll target completing the EAP Sense702 proxy and the lib version of it. Also we'll try to read through like some of the contracts here, which are like which looks interesting, because our target is not to complete the whole coverage but actually learn from it, right? So I'm like definitely gonna review majority of the code here, and let's see how does it go. Yeah, so that's it. And I'm targeting, so today is Thursday, I'm targeting to complete like majority of the code here by the end of Sunday, and wish me luck. Thank you, I'll see you tomorrow. Bye bye.